Hello and welcome back to Planet Nibiru. As always, I'd like to take a moment to thank everyone who subscribes, likes, and comments on our videos. As many of you know, one of the leading theories on Nibiru, or Planet X, is that we are part of a binary star system, and that our companion star swings by every so often with a few planets and a bunch of trash in tow to shower us with hot death and gloom and doom. Scientists have long questioned, do all stars start as part of a binary or multiple star system? According to the latest research, it's starting to look that way. Recent studies of stellar nurseries suggest that most star systems do in fact start out and spend their life in a multi-star configuration. Some lose their companions along the way, but that is somewhat rare, and rarer still to have a star that is born in a single star configuration. For years, scientists have posited that we are indeed part of a binary star system. This theory has a lot of support in the Planet X community, as many believe that Planet X is part of a small star system that makes its way through our larger system periodically, and it's believed that this Planet X system carries 5 to 7 planets, as well as tons of dust and debris, making it a cloudy system that may have a reddish tint when viewed from afar. This theoretical system has often been called Nemesis by those in the Planet X community. Oddly, modern scientists who research stars from their birth to their eventual death have chosen to also call this system by the name Nemesis. As it turns out, scientists from UC Berkeley have concluded that all stars are born as part of a multi-star system, and most of them remain in that formation, and very few actually lose their siblings and become single-star systems. As it turns out, single-star systems are rather rare, making our solar system all the more puzzling and unique. So does that mean that we have found our Planet X? Have we solved the mystery of where this periodic foe comes from and goes to when it's not wreaking havoc on our little planet? Probably not. Certainly not yet anyway. But we may be a whole lot closer if these latest studies are correct. So let's dig a bit deeper. Scientists Sarah Sadavoy and Steven Stoller were studying the Perseus molecular cloud, packed with newly formed stars, to determine what percentage of stars, like our Sun, form in pairs. The young stars within Perseus are less than 4 million years old. By comparison, our Sun is roughly 4.6 billion years old. Their notion that the majority of stars don't form as single stars isn't new. The question is more about numbers. Just how many Sun-like stars form as binaries, and how many stars form as single. So Sadavoy and Stoller took a long look at a dark molecular cloud named Barnard 68, which is filled with gas and dust that block light from stars forming inside as well as stars and galaxies behind it. These and other stellar nurseries, like the Perseus molecular cloud, can only be probed by radio waves. According to Stoller, astronomers have known for several decades that stars are born inside egg-shaped cocoons called dense cores, which are sprinkled throughout immense clouds of cold molecular hydrogen that are referred to as stellar nurseries. Through an optical telescope, these clouds look like holes in the starry sky because the dust accompanying the gas blocks the light from the stars inside and the stars and galaxies behind it. The Perseus molecular cloud is one such stellar nursery. It's about 600 light-years from Earth and about 50 light-years wide. Last year, a team of astronomers completed a survey that used the Very Large Array, a collection of radio dishes in New Mexico, to look at star formations inside the cloud. It was the first complete survey of all young stars in a molecular cloud. By young, we mean that these stars are less than about 4 million years old, and it includes both single and multiple stars down to separations of about 15 astronomical units. They also used existing data from a survey of every star in the Perseus stellar nursery. They ran a series of statistical models that took into account the numbers of both single stars and binary stars within the cloud. What they discovered surprised them. It appears that all Sun-like stars initially form as wide binaries, with about 500 astronomical units between them. And that's about 17 times the distance from Neptune to our Sun. Over the first million years of a star's life, the star systems either shrink into a truly binary system or they break apart, like our Sun and Nemesis. But will we ever find our Sun's lonely companion, Nemesis? It's highly unlikely. Based on this model, the Sun's sibling most likely escaped and mixed with all the other stars in our region of the Milky Way galaxy, never to be seen again. The likeliness of it being in a long-term orbit is pretty low. While this study has fascinating implications for what we know about how stars are born, it also underlines the fact that there's still a lot left to learn about our own star. That's why NASA is launching the Parker Solar Probe, which is the first spacecraft to touch the sun's atmosphere in 2018. So armed with the information that we have about most, if not all, stars forming as a binary or a multiple star system, the question is, what do you think? Do you think that we lost our binary partner star to the vastness of open space? Or do you think it still lurks around in a highly elongated orbit that brings it back home occasionally for a visit? We do know that 99% of all stars have at least one planet orbiting them, so it's very likely that if we do have a twin star, it probably has a planet or three orbiting it. So, do you think that Planet X is a system comprised of planets, debris, and a star? Or do you think it is one large planet that's just floating through out there? Could Planet X be our binary twin that was separated from us and is in some type of elongated orbit that only comes around every so often? Anything's possible, and we'd love to hear your thoughts. So let us know in the comment section. We'd love to hear any individual theories and discuss them with the community at large. Thanks for watching, and we'll be back with a new video soon.